Okay, so this is number 2 on quiz 3. I give you a chair and I ask you to draw it in a line structure. Okay, so first thing, it's a cyclohexane 6-membered ring chair. So go ahead and put your just a hexagon on there. And then this, well, ask yourself, is this cyclohexane chiral? Hit pause and think about it if you need to. I'm going to go ahead and tell you the answer, but you should be able to identify it. And the answer is, it's not. There's a plane of symmetry running through the middle of the board. That carbon, as I talked about in class, is not chiral. Right? It's bonded to an oxygen, a hydrogen, CH2, CH2, those tie, CH2, CH2, that ties, same atom. So it's got 2 identical groups bonded to it. The same argument can be made for this carbon. Methyl, hydrogen, tied CH2s, same atom. So the molecule's achiral. But it does have relative stereochemistry. This is trans, right? So if you look at these, all right, it's got 2 axial hydrogens, it's got equatorial oxygens and an equatorial OH and an equatorial methyl. You want to be really clear what group is what there, okay? So a lot of people are drawing the substituents coming off that like that, all right? They're drawing something where that's in between. I don't know what that is. I don't know what you mean that to be. So that atom is tetrahedral. There is an axial, there is a bond right there going straight up and down, then another one over here. If you simply draw a bond there, I don't have a clue what it is, and it'd be counted wrong, as by this time you no doubt have seen. Okay, so that's a trans cyclohexane. If we view this cyclohexane from the top, you could view it from any angle you want, but if you view it from the top, that OH is back, and the methyl would be sticking out toward you. In any case, you could have also drawn, you could have drawn the OH out at us and the methyl back. Those are identical structures. If you flip the second structure over, it overlaps perfectly with the first. That's because the molecule is achiral, so you can do that. So either of those answers is okay. You do have to have all the wedges and dashes there because it's a trans cyclohexane. All right, then the second part of number 2 was to draw this molecule as a chair. So again, let's draw a chair. There's a chair. It's not a very good chair, but what are you going to do? All right, I'm going to start with the isopropyl group. It's down. And again, it's probably a good idea at this point to put the hydrogens in, put the axial group in. I think most of you at this point are pretty good at figuring out where the axial substituent goes. You're less good, again, I saw a lot of these where you did this, right? That red line is wrong, okay? That's neither axial nor equatorial. There's actually not a substituent there. That substituent's only there if this carbon's sp2 hybridized. It's not, it's sp3, so make sure it's a tetrahedral atom. Okay, so now that you've put that isopropyl group in, I've sort of turned it this way and looking at it from above, so I'm going to go around the back. Right, so the isopropyl is down. Isopropyl's down. It's trans to the methyl on the carbon next to it. So if the isopropyl's down, the methyl on this carbon has to be up. So you've got 2 different substituents here. I've drawn a really bad chair. All right. So those bonds are back behind there. Again, that's a tetrahedral carbon. The axial is straight up and down. And the axial always points away from the other 2 bonds, right? So these 2 bonds come in like that. They're both pointed down. That means the axial has to be down. All right, so isopropyl is down. The methyl is on the up. That means that's an H. So that methyl on the back carbon there is equatorial. The H is axial. Okay, and now 1,4 to the methyl. So straight across the ring from the methyl is another methyl. So if we go 1, 2, 3, 4, there's a methyl on this carbon. And again, isopropyl is cis, so isopropyl is cis to the methyl in question now. So isopropyl's down, that methyl has to be down. This methyl is trans to the methyl, so if that methyl's up, that methyl is down. And so we get that either way. And so that puts the other H there. And so all three substituents are equatorial. I think only a few people put all three substituents axial. All right, so that's a mistake. Let me go through here and, all right, so that's down. That's up, and that is down. So again, cis-trans has nothing to do with axial or equatorial, because there are going to be 2 chairs to every cyclohexane. Every substituent will be axial in one chair, equatorial in the other chair. What doesn't change is the up-down relationship. So, and if we number these, let's go ahead and number the atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so the 2 and 5 methyls are trans. That means if the 2-methyl is up, the 5-methyl is down. And again, up and down refers to the substituents on a given carbon. So that this methyl is on carbon 5, it's down relative to the hydrogen on carbon 5. Okay, so you're not looking at other things. Up and down is just the 2 groups coming off of one carbon. So let's take carbon 1 that's got an isopropyl. The isopropyl is down relative to the hydrogen, which is up. On carbon 2, the methyl, the equatorial methyl, is up relative to the hydrogen, which is down. If you do a chair flip, that relationship will stay the same. The isopropyl stays down relative to the H on carbon 1's being up. But the equatorial isopropyl would then shift to being axial. Okay, that's the answers for those.